Hello, fourth grade, and welcome to Unit 1, Week 4 of Language Arts. We're going to go over your vocabulary words first today. Your first vocabulary word is the word gravity. Gravity is a natural force that pulls things on Earth towards the center. So it's a force that attracts you to the Earth so that you don't float away. So that's why when you jump, you come back down. Your second word is the word thrilling. Something that is thrilling is very exciting. So a roller coaster ride can be thrilling. A movie, if you're watching a scary movie, that can be thrilling. If you're going to a new place or an amusement park, something like that is also thrilling. Now, your next word is the word friction, and this is another science word like gravity. Now, friction is the opposite force between two things, and that's what slows or stops something from moving. So if you're rubbing your hands together, you can feel like it's hard to rub them together because one of them is pushing on the other in the opposite direction. Or if you're dragging your feet across the floor like a carpet, you can feel like the carpet is pushing against you. That force that's going against the way you're moving is called friction. Now, your next word is the word advantage. When you have an advantage, you have something that's helping you or that's useful to you in completing a task. So we can say one advantage that the basketball player had was that he was taller than the other players, right? Being taller in basketball is an advantage because it means you're closer to the basketball hoop. Another advantage you can say is the student had an advantage in the class because when the teacher gave a surprise quiz, the student had taken really good notes the day before. Now your next word is the word identity. Now your identity is who you are. Identity means what that thing is or what that person is. It's just who they are. Now our next word is the word capabilities. Capabilities comes from the word capable, and that comes from the word abilities, right? It comes from able. And capabilities are the qualities, abilities, or capacities. So capabilities are basically what you can do. So when you have, for example, a lot of you guys know a lot of your superheroes. If you have Ant-Man, right? Ant-Man has the ability or the capability to shrink down to the size of an ant. Hulk has the ability to change into the big green Hulk monster or back down to Dr. Banner. So your capabilities are things or qualities that you have, or they're things that you can do. Some of my friend's capabilities is that she can draw beautiful pictures. She's a wonderful artist. Another friend of mine, some of her capabilities are that she's an excellent writer. She can write really interesting stories. All right, your seventh word for this week is the word inquiry. An inquiry or an inquiry is a search for information. When you inquire about something, you're asking about something, so you're looking for information. So if I say, please direct your inquiry to the information desk, that means I'm telling you, please take your question over to the information desk because they would probably have the answer for you there. So an inquiry is a question that you have. To accelerate means to change speed of a moving object. So if something is moving kind of slow and then it starts to move faster, it is accelerating. So think about when you're in the car with any one of the adults in your family and they're going at a regular speed and then they get on the freeway and you see that they start to accelerate or they start to go faster because on the freeway cars drive faster than they do on the regular street. Now your spelling words for this week all focus on the long I sound and the different ways to make the long I sound. So your words this week are the word climb, minding, highs, die, height, sigh, fright, slight, drive, file, kite, prime, pride, slice, twice, wipe, pry, sly, shy, spy, chief, zebra, sleek, highway, and wildlife. So we've made the long I sound a couple different ways. We've made it with just the long I where it's an IE. A long I sound just by itself when it's only that single vowel in the word. EI like in height, IE like in pies, IGH like in the word sigh or fright or slight. We have an I consonant letter and then a silent E like drive or file. And then we have with a Y at the end like the word pry or sly. Now for grammar this week, we're going to be talking about different kinds of nouns. Now a noun is a word that names a person, place, or thing. And we have different kinds of nouns. We have common nouns and we have proper nouns. Now a common noun names any person, place, or thing. So if I say cat or dog or tree or friend or building, all of these tell me a noun, right? Some person, place, or thing, but it doesn't tell me specifically which one. It could be anyone. Now, a proper noun names is the name or a title of a specific person, place, or thing. So instead of saying the park, I can say the Wild Animal Park. Instead of saying the zoo, I can say San Diego Zoo. Now, proper nouns begin with a capital letter, and if they have more than one word in them, we're capitalizing each one of the important words. So the San Diego Zoo, I'm capitalizing the S and the D and the Z. If I say SeaWorld, I'm capitalizing the S in SeaWorld and the W, or the S and C and the W in world. Now, proper nouns, like we said, are also names. So your names are proper nouns. I'm not saying the students or the boy or the girl. I can say Zakaria or Faiza or Khadija. If I'm talking about a specific animal that has a name, I can say Shamu. If I'm talking about not any cat and mouse, I'm talking about Tom and Jerry. I'm not talking about any canyon, I'm talking about the Grand Canyon or Mr. Bob. If I'm talking about someone's nationality or race, I can say that they are Asian or they are African American. If I'm talking about a war, I'm not talking about any war. I'm talking about the Civil War. So all of these are things that require you to capitalize because they are the name of a person, place, or thing. Now, we also capitalize days of the week and the months and holidays. So any important words in the titles of a story or something that's published also gets capitalized. The names of different languages or races, nationalities, or historical events, all of these also get capitalized. So I gave you examples for each one of these different categories. So days, Monday, Tuesday, Wednesday, on and on and on. Those all begin with a capital letter. The months of the year, all of those begin with a capital letter, January, February, March. Any holidays, Memorial Day, Eid al-Adha, Martin Luther King Jr. Day, all of those have capital letters in them because they're the name of a specific holiday. Now, when we're talking about titles, like titles of books, we capitalize the first word and all of the other important words in the title. So the title of this book is The Mouse and the Motorcycle. So all of the important words, including the first word, are capitalized. The other words that are not important are lowercase. You can say Where the Wild Things Are is also another book title where we capitalize the first word and all of the other important words in it. Now, if I'm talking about different languages, I capitalize the first letter when I'm writing about those. So English, Spanish, Somali, Pashto, Dari, Somali. Oh, It's in there twice. Arabic, French, and so on. All the other languages, these are all different ones, and they all have to start with a capital letter because it's naming a specific language. So again, about different races, nationalities, historical events, also product names or geographic locations. So the names of different places in the world or the names of specific products. So an iPhone, Cinnamon Toast Crunch cereal, Dum Dum lollipops, all of those, because it's the name of a specific one, you need to capitalize it. When we're talking about geographic locations, we're talking about places in the world. So Lake Tahoe, Niagara Falls, the Grand Canyon, all of these are names of places in the world. Now we're also going to talk about two other kinds of nouns called concrete and abstract nouns. So this is a little bit different than what we were talking about. So a concrete noun names a person, place, or thing that can be identified with any of your five senses. So a concrete noun needs to be something that you can either see or hear or touch or smell or taste. So a child is a concrete noun, a book, a car, street, neighbor, flowers, basketball, ice cream, a sandwich. All of those are concrete nouns. There's things that you can either see or hear or taste or smell or touch. Now, an abstract noun is different. It names something about a person, place, or thing that cannot be identified with your five senses. So these are usually ideas. So honesty, freedom, trust, fear, courage, pride, joy, love, all of these are abstract nouns. They name an idea. You can't see honesty. You can't see trust. You can't see joy. You can see someone smiling because they're feeling joy, but you're not seeing joy itself. So these are all things that someone is or does. They're all a variation. They're all different kind of noun, but they're different, again, from concrete nouns because they are not things that you can identify with your five senses. I do have 3 videos down here for you guys to watch that are important, and they're going to be very helpful. Please go ahead and take the time to watch these. I'm not going to play them for you here. You can come into the notes in our shared 2nd, 3rd, and 4th grade shared folder, and you can click on each one of these and it will take you to the different videos that are related to it. I'm going to go ahead and jump into your weekly stories. So this week we're in Unit 1, Week 4. So you guys are going to be reading about a crash course in forces and motion. So that's why you had a lot of science words in your vocabulary.
Genre: narrative nonfiction. Essential question: how can science help you find out how things work? Read how forces and motion affect our lives. A crash course in forces and motion with Max Axiom, super scientist. About Max: super capabilities, super intelligence, able to shrink to the size of an atom. Sunglasses give X-ray vision. Lab coat allows for travel through time and space. Origin: since birth, Max Axiom seemed destined for greatness. His mother, a marine biologist, taught her son about the mysteries of the sea. His father, a nuclear physicist and volunteer park ranger, schooled Max on the wonders of earth and sky. One day on a wilderness hike, a mega-charged lightning bolt struck Max with blinding fury. When he awoke, Max discovered a newfound energy and set out to learn as much about science as possible. He traveled the globe, earning degrees in every aspect of the field. Upon his return, he was ready to share his knowledge and new identity with the world. He had become Max Axiom, super scientist. By Emily Sohn. Illustrated by Steve Irwin and Charles Barnett III. Forces that move us. Super scientist Max Axiom jumps right into the world of forces in motion at an amusement park. What a perfect day! And even though everything feels turned upside down, spinning, flying, jumping, and falling are just some of the amazing ways to move. But there's a lot of science behind the zoom around us. In fact, the world is full of all kinds of motion. Everything that moves needs a force to get it moving. Back for another jump already? You bet. A force is any push or pull on an object. Bungee jumping depends on a force called gravity. It pulls objects toward each other, and it keeps us on the earth. Gravity is the reason I fall down, not up or sideways. Phew! Moving can be thrilling, but I need a break. Snap, snap. Hi, Rosita. What are you doing here? Hello, Max. I'm taking notes for the physics class I teach. Why are you just sitting there? Is something wrong? Once I sit, sometimes it's hard to get moving again. But once I get going, I often can't stop. That's inertia for you. An object at rest tends to stay at rest. An object in motion stays in motion. That's Newton's first law of motion. A still object needs a force to get it moving. Likewise, a moving object needs a force to change its direction, slow it down, or make it stop. For instance, inertia keeps that stroller rolling. Whee! Until another force comes along to stop it. Aww. To cure your inertia, you just need a little push. Come on, let's go ride the roller coaster. Let's move. Isaac Newton. That's inertia for you. Another explained all motion on Earth in 1727. The roller coaster. Let's move. Isaac Newton. Isaac Newton, 1643 to 1727, was the first person to realize that certain laws of nature explained all motion on Earth and in space. He also was the first to explain the idea of gravity. Here we go. I feel like I'm being pushed to the back of my seat. That's inertia. When the ride starts, your body is at rest. When the chair moves forward, your body wants to stay at rest, but the chair moves into you. The chair's forward motion makes you feel like you're being pushed to the back of your seat. Wow, how does this roller coaster go so fast? The force of gravity is increasing our speed. Speed is how fast we are going at any given moment. Acceleration is how much speed we pick up as we go down the hill. Acceleration causes us to move more quickly at the bottom of the hill than we did at the top. That bar digging into my stomach must be inertia too. You got it. The ride comes to a stop, but your body wants to keep moving. The lap bar applies a force that keeps you from flying out of the car. So the lap bar stopped us from continuing forward on the roller coaster. What keeps that stone from staying in motion? Plop. Excellent question. You can't see it, but a force called friction stopped the stone. Friction happens when two surfaces rub against each other. On Earth, gravity and friction work together to slow things down and make them stop. Friction in space. In space, there is no friction. If you kicked a stone, it would keep going and going and going. That's why astronauts are tied to the space station when they do spacewalks. Otherwise, they just float away. Brakes on the roller coaster used friction to slow us down too. Come on, I'll show you how. Each roller coaster car has two brake fins attached to its underside. As the cars approach the station, these fins slide between two sets of brake rails. I see when the brake rails squeeze against the fins, friction stops the cars. I had a great time, Rosita, but I've got to run. My nephew is having his birthday party over at Skater's Paradise. See you later, Max. Picture label. Brake rail. Motion is a weighty issue. Juggling these bowling balls is wearing me out. I don't know why that guy is so tired. Juggling is easy. The juggler on the right is tired because he's using more force to throw and catch heavier objects. He's showing us Newton's second law. The amount of acceleration that a force can produce depends on the mass of the object. What's mass, Uncle Max? Mass is the amount of matter in an object. The bowling ball has more matter in it than the tennis ball, so it feels heavier. Think about it. Which ball would be easier to juggle, Nick? Gravitational pull. Weight is different from mass. Weight is determined by gravity's pull on an object. Each planet in our solar system has a different gravitational pull. If you travel to each of the places below, your mass would always be the same, but your weight would be different. Multiply your weight by the numbers shown below each planet to find out how much you would weigh there. If you weigh 100 pounds on Earth, you would weigh 38 pounds on Mars and 236 pounds on Jupiter. Venus, 0.88. Mars, 0.38. Jupiter, 2.36. Saturn, 0.92. Neptune, 1.13. I have another way to think about Newton's second law. I need 2 volunteers. Pick me. I'll do it. I'm going to push both of them with the same amount of force on a level surface. Who do you think will accelerate faster? Johnny's bigger. He'll go faster. Jenny's an awesome skater. She'll win. Both of my arms are equally strong, so the amount of force will be the same. Let's see who gets a faster start. Like the tennis ball, Jenny has less mass than Johnny, so she gets a faster start with the same push. Johnny would need a stronger force to get moving as quickly. I'm like the tennis ball. Does that make me a bowling ball? Uncle Max, Jenny won the race on a flat surface, but I've noticed that the bigger kids always travel farther than the smaller kids when skating down a ramp. Sometimes having more mass can give you an advantage. Let's have Johnny and Jenny race again. In the last race, we wanted to see who would get a faster start. This race is for distance. I'm going to release you at the same time. We'll see who travels farther without pumping. Johnny's got it in the bag. No way! Jenny will beat him easily. Stop and check. Make predictions. Who will travel farther when released down the ramp? Use what you learned about forces and motion to make a prediction. Do you see that? Gravity pulls them down the ramp, but Johnny travels farther than Jenny. Max, what happened? I got a good start, but Johnny just passed right by me. Johnny's larger mass takes more force to slow down or stop than your smaller mass. Friction between your wheels and the ground was the main force slowing both of you down. Johnny needed more friction to stop, so he traveled farther. Time for cake! I don't think these kids will let a little friction stand between them and chocolate cake. Genre: Science fiction. Compare texts. Read how 2 futuristic robots use science to solve a problem. The Box Zip Project. The 13th sun of Zyport rose in the orange-tinted sky as Dr. Tank and his assistant, Shine, arrived for work. "Good morning," Shine said, slipping into his lab coat. "Today's the day. I feel it in my battery." Dr. Tank smiled and said, "Now, Shine, we don't feel. We are robots, remember?" Shine's robot laughter clattered like marbles inside a can. "You got me, Dr. Tank, but honestly, I think we'll figure out the problem with this silly machine today." The silly machine, known as Box Zip, stood in the middle of the science laboratory, looking like a ticket booth. "Let's hope so, Shine. This project will be history if we're not successful pronto." For months, the robots had been attempting to travel in the Box Zip to Earth. A voyage to planet Exto was no problem, and it was twice the distance. They could land on Grolon in a heartbeat. When they traveled to Vinzine, they returned 10 minutes before they even left. But Earth? Every time they attempted landing on that bizarre planet, they could only get so close. "Time for the morning checklist," Dr. Tank said. "Ready-o," Shine answered. "Inertia?" inquired Dr. Tank. "Check," said Shine. "This baby is definitely at rest. Superb. Now let's apply force to move it," Dr. Tank said. Together they pushed Box Zip, which slid easily. "Now use force to stop it," Dr. Tank said. Shine held out his enormous robot hand and immediately stopped the sliding Box Zip. "Let's do a trial run to Clugger and back," said Dr. Tank. Both robots stepped into Box Zip and buckled up. "Accelerate to warp ×5 blinkers," Dr. Tank advised. As Box Zip moved faster, the seat belts kept the robots in place. Exto, Vinzine, earth, grolon. Almost instantly, Bach-Zip glided onto a dusty purple planet. Shine wanted a purple frozen beverage from the 7012 store, but Dr. Tank explained that there was simply no time. In 5 blinkers, they were back in the laboratory. Clugger is no problem, yet we can't manage an Earth landing, the frustrated Dr. Tank said. It's ridiculous. Come on, Shine encouraged. Giving up is not an option. Dr. Tank couldn't help but smile at his unfailingly cheerful assistant. Now he regretted not letting Shine get a purple frozen beverage on Clugger. You're absolutely right, said Dr. Tank. Let's try Earth again. Buckled safely in Bach-Zip, Shine began to accelerate to warp time 7 blinkers, then 12 blinkers. The world was a distorted blur of colorful motion. The robot's chrome teeth chattered as they whizzed through the galaxies, finally landing with a thud. They peered out the window. Drats! Dr. Tank shouted in frustration. It's happened again. We'll never make it all the way down. Shine looked down. There was Earth below, yet Bach-Zip remained at least 15 feet above, stuck in the many arms of some enormous green and brown structure. Why can't we get to Earth? Dr. Tank cried. Yoo-hoo there, came a voice from below. The robots looked at each other. Something was attempting communication. Yoo-hoo, the voice called again. Maybe yoo-hoo means hello, said Shine. Let's try to communicate. Shine leaned out the window calling, Yoo-hoo! Might I possibly make an inquiry? The Earth creature said. An inquiry? Asked Shine. A question. Might I ask a question? Certainly, answered Dr. Tank. And then we'll ask you a question. Very well, said the creature. Did you mean to land in a tree? Tree? Said Shine. What a hilarious name for this funny-looking thing. Your tree prevents us from landing on your planet, said Dr. Tank. Is there something we can do about it? The creature nodded his head. I believe that gravity might offer a solution. Try rocking back and forth a bit. Once you start falling, I'm sure you'll come all the way down. The robots looked at each other doubtfully. Still, they shifted from side to side until Bach-Zip began to move. Then it moved down. In fact, it moved down rather quickly. Yes, Dr. Tank shouted. We've landed on Earth at last. To prove their successful landing, the robots had photographs made with the Earth creature, whose name turned out to be Mortimer. With some special sticky tape, Bach-Zip was soon patched up and ready to go home. Before leaving Earth, Dr. Tank bought Shine a delicious green frozen beverage for the trip home. Earth friend Mortimer. Genre: narrative fiction. The Big Race. This race car simulator is cool. Let's try it. Essential question. How can science help you understand how things work? Read how Alex and Liam want to use science to help them win a race. Alex and Liam plan to build a car for the Soapbox Derby. As a result of their inquiry into how to build a fast car, they had come to the Science Museum today for answers. Last week, Alex's mother had called one of the museum's scientists. When they walked into the museum, a woman in a lab coat and inline skates zoomed up and greeted them. Hi, I'm Clara. Are you the boys who want to know what will make a car go fast? Yes, I'm Alex, and that's Liam, Alex responded. Why are you wearing inline skates, Clara? Liam asked. I'm a champion skater, Clara claimed, doing a spin. Then she whispered, That's not my true identity. I'm a scientist. Skates make it easier to get around. Follow me. It's about speed. Welcome to our On the Move exhibit, Clara announced as they entered a large room. So, tell me about the race. There will be 20 cars in the race. We'll be going down the steepest hill in town, Alex said. Sounds thrilling. It must be exciting to go fast, Clara answered as she pressed buttons on a machine. This is a virtual race car, and this screen shows you the virtual race course and your speed. Speed is the distance an object moves in a certain amount of time. I'm Clara. Welcome. Forces at work. Alex and Liam climbed into the machine. Each seat had a steering wheel and a screen in front of it. Clara said, Since you want to build a fast car, you need to know about forces and how they affect motion. What's a force? Asked Liam. Clara continued, A force is a push or a pull. Forces cause things to move or cause a change in motion. When I apply a big enough force on an object, like this stool, it moves. If two objects are exactly the same, the object that receives a bigger force will accelerate or increase its speed, Clara said, pushing two stools at the same time. Which stool received a bigger force? Clara asked. The one on the right. It went farther, said Liam. So, giving our car a big push at the top of the hill will cause it to accelerate and go faster, Alex summarized. A force is a push or pull. There's a sharp curve coming up. I'm going to accelerate now. Gravity and friction. Clara smiled. Right. Another force acting on your car is gravity. Gravity is a pulling force between two objects. Clara took a tennis ball out of her pocket. When I drop this ball, gravity pulls it towards the floor. It's the same force that pulls your car down the hill. So a big push gives us an advantage over other cars, and gravity will keep us going. How do we stop? Liam asked. You'll need friction. Friction is a force between two surfaces that slows objects down or stops them from moving. For example, I lean back on my skates, and the friction between the rubber stoppers and the floor slows me down, said Clara. Thanks, Clara. The virtual race car was cool. I knew we had the skills and capabilities to win the race, but now we have science on our side too, Liam grinned. You need friction.
Okay, so we're going to go ahead into our comprehension skill and strategy to help us get a better understanding of the text. Now, this is a concept that we did talk about last week, I believe, when we were talking about rereading, which means to read something again. That way it helps you catch up on anything you may have missed or skipped over by accident. Then we're going to talk about cause and effects, where we're going to learn about the relationship between different things in the story.
Reread. When you read an informational text, you often come across information that is new to you. As you read The Big Race, reread key sections of text to make sure you understand them and remember the information they contain. Find text evidence. As you read The Big Race, the concept of acceleration may be new to you. Reread the Forces at Work section on page 66 to help you remember what accelerate means. What's force? Asked Liam. Clara continued. A force is a push or a pull. Forces cause things to move or cause a change in motion. When I apply a big enough force on an object, like this stool, it moves. If two objects are exactly the same, the object that receives a bigger force will accelerate or increase its speed, Clara said, pushing two stools at the same time. Which stool received a bigger force? Clara asked. The one on the right. It went farther, said Liam. So, giving our car a big push at the top of the hill will cause it to accelerate and go faster, Alex summarized. There's a sharp curve coming up. I'm going to accelerate now. I read that accelerate means to increase the speed of something. Rereading will help me to understand and remember this concept. Cause and effect. Text structure is the way that authors organize information in a section. Cause and effect is one kind of text structure. The author explains how and why something happens. A cause is why something happens. An effect is what happens. Find text evidence. I can reread Forces at Work in the Big Race on page 66 to find actions that cause something to happen. Then I can figure out the effects of those actions. Graphic organizer. Cause. Effect. Cause. Clara applies force to one stool. Effect. The stool moves. Cause. Clara pushes both stools. Effect. Both stools move. Cause. Clara applies more force to one stool. Effect. One stool moves farther.
Now we're going to talk a little bit more about our genre. So we're still working with informational text, and we're talking about a narrative nonfiction. So a narrative nonfiction is a story that's being told by the person it's about, and it's nonfiction, which means it really happened.
Narrative nonfiction. The selection The Big Race is narrative nonfiction. Narrative nonfiction tells a story, includes facts and examples about a topic, often includes text features. Find text evidence. Even though The Big Race reads like a story, I can tell that it is an informational text because it includes facts and text features. Text features. Headings. Headings tell what a section of text is mostly about. Speech balloons. Speech balloons tell what the characters are saying or thinking.
Okay, so next we're going to talk about our context clues, and these are things that help us understand words or phrases in a text that we may not already be familiar with. So we use clues from the words and sentences around us to try and figure out what that thing means.
Context clues. When you are not sure what a word means, you can look at the other words around it to figure out the meaning. These other words, called context clues, may be definitions, examples, or restatements of the word's meaning. Find text evidence. When I read the fourth paragraph on page 66 of The Big Race, I am not sure what the word force means. The phrase, a push or a pull, defines what the word force means. Clara continued, a force is a push or a pull. Forces cause things to move or cause a change in motion.
Now we're going to go over some of the things that we covered in grammar by reviewing this piece of writing.
In The Big Race, the author's purpose is to explain what will make a car go fast. Alex and Liam want to build a car for the Soapbox Derby. Before they build it, they decide to visit the Science Museum for help. While the boys are driving in a virtual race car, a scientist explains the different forces that affect motion. By the end, the boys know how to build their race car, and the reader understands how forces affect motion. Author's purpose. My first sentence states the author's purpose for writing The Big Race. Sequence. I organize my writing in logical order by using linking words such as before. Grammar. This is an example of a complex sentence. Strong conclusion. My final sentence sums up the author's purpose.
Okay, so that takes us to the end of our notes for this week for Language Arts, 4th grade. If you have any questions, definitely let me know. Please make sure you're doing your work neatly and completely. Make sure your name and date are at the top of all of your pages and that you are following all the directions on each section as you do them. If you have any questions, let me know. Otherwise, I hope you have an amazing day.